Okay, welcome to the next virtual office hours for the POSA MOOC. We will wait a couple minutes and let people join, and then we'll go ahead and get started. If you join and you can hear me, please go ahead and let me know. I'm assuming it's working. Looks like it's working. All right, it looks like some people are joining, which is good. We'll start up in just a second as soon as a few more people join. Naturally, if you have any questions, please don't hesitate to ask them, and I'll be happy to answer them once we get up and running. Okay, looks like we got people joining. We'll start in just a second. Okay, let's go ahead and get started. Welcome to the next live lecture and virtual office hour for the POSA Concurrency MOOC. What we're going to be doing today is focusing first and foremost on my solution to programming assignment number 1, so you can go ahead and use that as the basis for the peer grading that you'll be doing. And then after that, we'll also walk through another example to give you some more illustrations of how to write good object-oriented and pattern-oriented concurrency code. And then I'll be happy to take any questions that you might have about anything that we're discussing. So without further ado, why don't we go ahead and take a look at my solutions for programming assignment number 1. Let me go ahead and get my screen to a point where I can share it. And then we will go ahead and start to discuss. Let's see. Okay. So share the screen. Hopefully everybody can see this up on the screen. This is my solution. Now, if you recall the assignment, you only had to go ahead and address a couple of points. There were just a couple of files that you had to fill in. And so here was one of the files. This is the Palantir Manager file. And let's go ahead and search for the to-do statements. So one thing you had to do was provide the Palantir Manager constructor. And this constructor was given a list of the Palantiri that were going to be used by the beings to gaze into, and it had to go ahead and create the appropriate data structures and initialize them. So down here, we go ahead and create a new Palantiri map, which is implemented as a hash map. Notice this is just a good old garden variety hash map. There's no need here for concurrent hash map. That's the next assignment. So we just make a hash map and then we walk through the list of Palantiri, and for every element in there, we take each Palantir from the Palantiri list, and we put it into the map, and we set its in-use flag to be, or rather its is available flag or is available for use flag to be true. And that means that this Palantiri is available. Nobody's using it at this point. We then come down here, we make a new semaphore, which is given the size of the number of Palantiri, which defaults to 4. And we set that to true. And that true means that this will be using a fair implementation. And so it's going to basically do a round robin access of waiting beings who are going to be running in threads trying to acquire a Palantir. So that's basically how that works. So that's that method. Pretty straightforward, just initializing some data structures. Here's acquire. First thing acquire does is it acquires the semaphore, and it does that uninterruptibly. It doesn't want to be disturbed while it's blocking, waiting to get the next available Palantir. And if there are no Palantiri available, then that call will block until there's a Palantir that's available. If there is a Palantir available, this call will return right away. In either case, the count will be decremented by 1 when it's gotten the semaphore. We then come along here and we use a synchronized block in order to access the map of Palantiri. And what my implementation does, I think this is probably the most efficient way to do it, I get myself something called the entry set, which is the set of key value pairs. And each of these, each entry is an entry object that has a Palantir and a Boolean indicating whether it's in use or not. And then we check to see whether or not the value is true. If the value is true, that means that the Palantir is available. And so then we go ahead and set the value to be false. And then we go ahead and we return the key. And the nice thing about this is that it will just search through and find the first entry in the map that's available, set it to false, and then return the key that was associated with that value. And notice how it does this inside a synchronized statement. So the synchronized statement will ensure that the access to the map is guarded properly. Here's the release method. This comes and does a simple sanity check first, just to make sure we're not giving an incorrect Palantir. We then set a flag called call release to false. You'll see how that gets used in a second. We then have a synchronized statement. This synchronized statement is needed because we want to be able to update the value in the hash map and change it from false to true, because we want, of course, to have it be available again. And as we had talked about in the last class, the one that we had done earlier, there's a bug in the documentation for Java hash map. And even when you only change the value, you still need to hold this, you still need to acquire a lock in order to make sure that the change to that value becomes visible to other threads in a timely manner. So this will ensure visibility is handled properly. So we go ahead and put the Palantir key back with the value of true, and this will return the old value. And if the value we had here before was false, then we're okay. That means that it was previously false and everything's all right, in which case we set this flag to true, and then we release the lock. And now, once we've released the lock, we can check to see whether or not that flag was set or not. And if it was set, then we go ahead and release the Palantir. And we just do this. We do this like this for two reasons. First, we want to do a little sanity check to make sure that things are working properly. And if they aren't working properly, we should probably log it or throw an exception or something. And then the second thing that we do is we're doing this check outside of the synchronized statement, because we want to keep the critical section over which the synchronized statement applies to be as fine-grained as possible, because that'll maximize the opportunities for concurrency in the solution. Okay, so that's how the Palantir Manager worked. Pretty straightforward. Let's go ahead now and take a look at the, come on. Go ahead and take a look at the other implementation, which is the Palantir presenter. We had a couple things we had to do there. Whoops. So we had two methods that we had to handle. One of them was we had to create the beings threads, and then we had to create the join thread that was going to wait for all the being threads to exit. So here's the begin being threads method. We come in here, we make a new array list, we iterate through the array list, and from I equals 0, I less than being count. And then for each of these things, we're going to go ahead and make a new being thread. And a new being thread, as you can see here, is going to consist of a being runnable, a new being runnable. The index, the item it is, it's the ith being. Beings are numbered from 0 to being count -1. And then we pass in this as the value that we're going to be using for the Palantir presenter, which we're going to need for various reasons inside of the being thread or being runnable in order to get back to some of the methods that are provided by the Palantir presenter. And rather than create a new Palantir presenter, which would just be unbelievably complicated and overhead is excessive and just wrong, we just pass in this. And those are then held as weak references internally to the being runnable and being thread. So after we've made a new being thread with the right being runnable, we will then go ahead and get them all added. And then we go ahead and we start them all. Now, I could have started them at the same time I created them, but I just decided to do one loop that was going to create them, and then another loop that was going to go ahead and start them. And that way, they're all going to be started at roughly the same time period. If I wanted to make sure they all started at exactly the same time period, I would use some kind of synchronized barrier synchronizer, and the next assignment does that. So we start all the threads in the list of being threads, and then here's the wait for beings threads. And so what this does is this comes along and it creates a new runnable, and the run method of the runnable will simply loop through all the being threads that we created in the earlier method, and it's going to join with each one of them in turn. And if something goes wrong, if an exception occurs, then we shut everything down. Otherwise, this guy just blocks until everybody's done. And finally, after all the being threads are finished, we go ahead and say, tell the UI thread running in the view layer that we're finished. And so we just say mview.get.done. And that will go ahead and tell the UI thread running in the view layer that we're all finished. And that'll shut down the program. You can see that we create a new thread with a new runnable, and then we start that thread. So that's basically how the code works. Not too complicated, really, but it's an interesting example, and hopefully you did more than just did the minimum set of things in order to get this working. Hopefully you took some time to take a look at the overall structure of the example. I went ahead just for kicks, and I put a new video up on the website. Let me go find that for you. So if you go over here, and let me share my screen for a second. If you go over here, then, oops, wrong thing. Let's go get the, hold on. There it is. Okay, so hopefully you can see this. If you go up here and you go over to the video lectures, I just uploaded a video that shows execution of my solution for programming assignment number 3. So if you take a look here, assignment 1, sorry, for in week 3, I'm showing assignment 1 solution demo. If you click on this, it basically is me running my program and showing what the output should look like and showing how it behaves properly when things get rotated and so on. And the reason it behaves properly when it's rotated is because it's using the model view presenter pattern, and that's shielding the threading layer, which is in the presenter, from all the things that are taking place when the activities in the view layer are created and destroyed. Okay, so I'll be happy to take any questions. Here's a question: is there any difference if we call synchronized this or synchronized M planetary map? No, they both work exactly the same. One uses the intrinsic lock that's part of the planetary map, which is in this case is this, and or sorry, that would be the planetary manager, and then the planetary map is just another object that also has an intrinsic lock that's part of it. But most people would be more likely to expect to see synchronized this, but you can do whatever you want. As long as you're consistent, everything should be fine. Okay. By the way, I should also mention something else kind of interesting. In upcoming versions of Java, what I'm about to say is probably Java 10, they're going to have a new feature called structs. And structs are going to allow you to have just plain old data as opposed to classes, which also contain all this other gobbledygook like the intrinsic lock and the intrinsic condition and so on and so forth. So for people who are doing very data-centric processing, things like big data analytics, structs in Java 10 or whenever it comes out will give a much more space efficient and perhaps time efficient in some ways means of being able to manipulate data. So keep your eyes out for that. That'll be coming down the road. Okay, so sounds like there are no more questions for programming assignment number 1. I will make this into a video and we'll put it up on the website so everybody else can watch that in order to understand how to do the QA or the peer assessment part for programming assignment number 1. All right, the next thing I'd like to do here is I would like to show another example of concurrency. So let's go ahead and share the screen. So the example we're going to talk about now is a more interesting implementation of the image downloads app. We had shown an example of the image downloads app a couple days ago, and that one was very simple. This one is more interesting. It uses more advanced object-oriented design. It uses more advanced patterns, and it also addresses one of the grave deficiencies with the previous version, which didn't have support for handling screen rotation. You can download this app here at this link if you want to follow along. This solution, unlike the earlier one, uses the model view presenter pattern to handle runtime configuration changes. So we have the view layer, which handles all the interactions with the user. That's called image downloads activity. We have the presenter layer, which concurrently mediates the interactions between the view and model layers, and that's where it's got all the different implementations. And then the final thing we have here is the model layer. And the model layer interacts with the remote web server and will actually be the part that downloads the image. So those are the various parts that we're going to be taking a look at here. And what we're going to do now is actually go look at the source code for this. All right, so let me bring up my source code and let me share my screen. Okay, so here is the source code that we're about to look at for the image downloads application. As you'll see in a second, there's really just a single activity, the image downloads activity. That's where all the action starts with respect to interacting with the user. Let's take a look at the implementation. As you can see, this is split up using our canonical model view presenter pattern approach. And so we have an MVP file, which defines the various interfaces that the different layers require and provide to each other. So, for example, here's the view, the operations that are exposed by the view layer to the presenter layer. So it's able to, the presenter layer can call back to display a bitmap. Here is the interface that's provided by the presenter layer to the view layer, which handles button clicks. Here's the operations that are provided from the presenter layer to the model layer. And there's some things that are done there. Then finally, we have what's actually used inside the provided by the model layers. This is what's provided to the presenter layer. Okay, so those are some of the various features that we've got in this code. Let's take a look at the view layer. As is almost always the case in the model view presenter pattern, the view layer is really there just to interact with the user. And you'll see it's pretty simple. It extends generic activity, and that allows us to be able to use the magic of the model view presenter pattern to be able to create the presenter object in the presenter layer, and then have the presenter object and the view object in the view layer, the activity in the view layer, interact with each other without revealing too much about their implementation. In fact, the only things that they can actually call are the things that are defined in these interfaces. So the required view, which is what the view layer is presenting to the presenter, and then the provided presenter, which is what the presenter is providing to the view layer. And then we define what we want the framework to use as our factory class to make the object that will implement the presenter layer. And then, of course, the image downloads activity implements the required view ops. So that's what it's going to have to fill in, and that's what will be able to be called back by the presenter layer. We have a couple of fields here that we're going to use to indicate the URL to download and the image to view. Here's the Oncreate method. It goes ahead and calls up to the superclass to initialize things if necessary, sets the content view, assigns the various view fields, and then calls up to the generic activity in order to have the generic activity create an instance of the image downloads presenter class, which is going to serve as the presenter object in the presenter layer. And it also passes in the this field for the view layer, so that can be passed appropriately to the callback methods in the presenter layer. So it's basically just doing some kind of connecting up so that everybody knows about what they need to know to talk to each other. Here's the main entry point. When the user clicks a button, whatever they click, whether they click run async or run messages or run async task or run runnables or whatever they call, that's going to go through here. That's going to hide the keyboard, and then it's going to go ahead and forward that button click to the presenter layer. You can see we say get presenter dot handle button click. We pass in the user the ID of the button that was pressed, and we also give the URL string that the user provided. So that's how we interact from the view layer to the presenter. Here's what happens when things are finished in the presenter layer after it's successfully downloaded the image. It's going to call display bitmap, and this will then go ahead and do a little sanity checking. So if it's running in the UI thread and it got a null image, then something was incorrect. You give the wrong URL or something. Otherwise, if it's running in the UI thread, it goes ahead and sets the image to be the bitmap that was downloaded. It sets that to be the image view contents. And then if there was a completion command, it'll go ahead and tell the completion command we're finished. And that's basically a way to inform the presenter layer that everything's done, and it can go ahead and free up resources or do whatever it needs to get ready for the next request. If it turns out that display bitmap was not called in the UI thread, but was called in a background thread, it just turns around and creates a runnable that runs this in the UI thread. And so it's kind of an interesting recursive call. Notice display bitmap will call itself if it's not called from the context of the UI thread. And what that'll do is that'll end up getting the image to be called in the UI thread. So that's a clever little idiom we see a lot in Android. So that way you can call that method from anywhere, and it'll do the appropriate steps in order to make sure that the right processing takes place in the UI thread. Here's the get URL string that simply goes and looks at the edit text and grabs the string associated with it, whatever the URL was that was passed in. Okay, so that's the view layer. Very simple, just basically getting data from the user and showing the results back to the user. Let's now go ahead and take a look at the model layer. That's also very simple as well. So we have image downloads model. This implements the model interface, and it has a default URL that it'll download if you don't give it one if you don't override it by the edit text window. We keep a weak reference back to the presenter, and that allows us to be able to do various things if we need to. We have an Oncreate method that sets that weak reference, and then here's the download bitmap file. All this download bitmap method does sorry, it's not a file, it's a method. All this thing does is it takes a string and it calls out to the download and decode image in the utils directory. And what that does is that goes ahead and downloads the image and converts it into a bitmap. And you can see if there was no string that was given here, we go ahead and use the default string as the URL for downloading the file. So that's basically how we're going to do the work. If you were to go over here and look in utils, you would see that there's a bunch of methods that do various things that are helpful, like hiding the keyboard or showing the toast. And one of the things in here is actually, here's something called run on UI thread that checks if you're running on the UI thread. And download and decode image is basically going to go out and download the image using a URL object. And if it works, then it's going to go ahead and decode that, which comes back as an input stream using the bitmap factory decode stream. And that turns it into a bitmap. Otherwise, it'll either throw an exception or return null, depending on what kind of error you get. OK, so that's the model and the view layer. Here's the presenter layer. This is a little bit more interesting because this is where the cool concurrency stuff gets done. Here's the entry point into this thing. This is the presenter, image downloads presenter class. Image downloads presenter is a generic presenter. So that means that it's going to implement the required ops the presenter provides. It's also going to have various provided model ops that the model layer is going to be offering up to it. And it also gives the class to use to define the model layer implementation. And it implements required and provided presenter ops, keeps a weak reference to the view layer so the garbage collection will work properly. It has an instance of something called button to image strategy mapper. You'll see what that is done, how that's used in a second. It's a very cool little technique that makes the lookups really fast and convenient. We keep track of something called the active image strategy. There's different image strategies. There's 4 of them, one for async task, one for handlers and messages, and one for handlers and runnables, and then another one that resets things. So that's the active image strategy. We also keep track of the current image that we need if we're going to redisplay things after a runtime configuration change occurs. And then we also keep track of what's called the default image, and that's the image to display when the reset image button is pushed. We need a constructor that's a no-op constructor for the generic activity framework. Here's the Oncreate method. This is the method that's called the first time the presenter layer is initialized. So the first time in, Oncreate is called. It makes a new weak reference to the view layer so we can get back to it. And then it goes ahead and it initializes the button to image strategy mapper object. And it creates a new instance of something called the button to image strategy mapper, which is essentially going to have an array of, say this needs to go like this, I think. It's going to have an array of buttons. These are the button IDs. So this is the different buttons that can be pushed on the user interface. And each of these buttons, or rather each of these IDs, is going to be mapped to a different image strategy corresponding to that button. So when the Runnable button is clicked, that's going to call the download with Runnables object. When the messages button is clicked, that's going to call the download with messages button, or sorry, object. When async task is clicked, that's going to call the download with async task, and so on. So this is just a super clean way of being able to associate buttons with strategies that handle those buttons. And you'll see it's real easy to plug these strategies in using the good old strategy pattern from the Gang of 4 book. We then come down here and we create a default image, which we're going to use in order to have a default image for everything, which will just be the thing that you use when you start. And every time you get tired of what you've downloaded, you can click that and you go back to the default. And we store that here in the default image object. We then reset the bitmap, so that'll show the default image on the screen. And then we go ahead and invoke the Oncreate method in generic presenter, which creates the model instance in the model layer and connects that with the presenter instance that we're creating here in the presenter layer. So that's what gets done the first time in, just does a bunch of initialization calls. This method here, which is called onConfigurationChange, this gets called back every time the activity is destroyed and recreated. In other words, every time a runtime configuration change occurs. And what that does is that goes ahead and resets the view to point to the new view that's passed in, which will eventually be connected but to an activity that was created after the old one was destroyed. And then we also go ahead and we display the current image. Whatever the current image was, we display that. And that allows us to be able to update the user interface properly whenever the orientation changes. So those are some real clean ways of doing this. How it works. Okay, there's a couple more methods here that are worth looking at. One of the methods is called make download context, and you'll see how make download context gets used here in just a second. Make download context is used to make the context object that's needed by the various strategy instances. If you read the strategy pattern right up in the Gang of Four book, you'll see that a strategy is associated with a context, and that contains all the information that you would not otherwise have access to if you only relied on the simple parameters passed to each strategy instance. So take a look at the strategy pattern if you want more information about what a context is. We go ahead and create the information we need here, and this is going to first create something called a completion command. And when this run method is called, that basically is used to indicate that we're done with processing the image, so we no longer have an active image. And then we go ahead and create a new context object. And the context object contains the URL that we're going to be downloading, the various references to the view layer, the presenter layer, and the model layer, and then also the completion command. So this is what's going to be passed to the various strategies who need to use this in order to do their thing effectively. Here's the handle button click method. This is the one that's used when someone clicks on a button like run async or run runnables or run messages and so on. This passes in the button ID, the resource ID for the button, and the URL that was provided by the user. This is, of course, what's called by the view layer. We take the URL that's passed in and we make a new download context for that. We check to see whether or not there's an active strategy that's already in place. If there is not an active strategy, in other words, if we're not in the midst of downloading something, we're fine. If there was something that was already being downloaded, this implementation is simply going to cancel the existing download and start a new one. And we'll see how that works in a second. That, of course, is not the only way you could do this. There's lots of other ways to implement this. This is just to illustrate how to do cancellation. We then go ahead and use the button to image strategy mapper to get the image strategy that's associated with the button that was pressed. We set that to be the active strategy. And then we say to the strategy that's active, download and display yourself. So download and display is a strategy method, and that's passed the download context. And that download context is then used by the strategy to carry out the concurrent processing that it implements. And we'll take a look at that in a second and see how that works. Here's a method for setting the concurrent image, and here's a method for resetting the bitmap. And so you can see when we set the current image, that's used. Once we've got an image, we set that, and reset bitmap is used to set the current image to the default bitmap, and then we're going to go ahead and display the default bitmap. Okay, so that's how that stuff works. Now let's go take a look at the really interesting part from a concurrency point of view, and these are the strategies. So we'll take a look. There's an interface called image strategy, and each of the different concurrency models, the async task, the download with messages, and the download with runnables, is each going to implement the interface strategy. So here's interface strategy, or sorry, image strategy, not interface strategy, image strategy, which is an interface. This has two methods, download and display, which takes a download context, and cancel, which also takes a download context. So what that means, of course, is all the different strategies have to implement that particular interface. Let's take a look at the reset bitmap. That one's really simple. What reset bitmap does is it implements image strategy, and when you click the reset bitmap button, it goes ahead and simply pops a toast saying resetting image to the default, and then it resets the bitmap. and that'll go ahead and put the default image back on the screen. Cancellation is a no-op because it's not really doing anything in this case. It's not doing any concurrent processing. It's just replacing the bitmap that's on the screen with a new one. So that's what reset bitmap does. That's the easiest one. And there's a bunch of other strategies here, and I'll go through them one at a time. Let's start with the easiest one, download with runnables. So download with runnables implements image strategy, and it stores a thread, and that's the thread that's going to be used for the download. And we store this so that we can cancel it if we need to later. Here's the download and display method. This is overridden from the interface we implement. This goes ahead and makes a new runnable. The run method in this runnable will go ahead and ask the download context to download the bitmap given the URL that the context keeps track of. And if everything goes according to plan, that will download the image and store it in this local variable. And then we call download context display bitmap, passing the image in, and that will get the image routed correctly to the appropriate UI thread. It'll get it routed to the UI thread. So even though this display bitmap method is actually called in a background thread, it knows how to get itself running on the UI thread by that technique, that idiom we showed before, where that method in the activity checks to see what thread it's running in, and if it's not running in the UI thread, it creates a runnable and runs it in the UI thread. So this is the runnable. We pop up a toast saying what we're doing. Then we go ahead and start a new thread, or we create a new thread with that runnable, and we start that thread. And that thread will then start downloading. Now, if the user comes along and tries to download a new image before the current one is finished, then that'll call cancel. And cancel will display a toast saying we're canceling the download, and then it'll go ahead and interrupt the thread. And so that will help to shut down the thread as the time permits. Okay, so that's download with runnables. That's pretty straightforward. Here's download with messages. Same general concept. So we have download with messages, which implements image strategy. It has a thread too. It keeps track of a few messages that we're going to use here in order to be able to send the information from one thread to another. The download and display method creates a new handler. And this handler has a handle message method. And this handle message method takes the message that's passed to it, takes a look at what message ID was passed in, which is either a toast or a display image. If it's a toast, it creates a toast that says we're downloading with handlers and messages. If it's a display image message, it goes ahead and tells the download context to display the image given the message object that's passed in that contains the bitmap for the image. Here's the download runnable. It looks similar to the one we did before, but it has a few more steps because it's message oriented. So what it does here, when the run method is called, it makes a message that says show toast. It sends that message to the message handler. Here's the message handler. The message handler, as in this case, will show the toast. Message handler is running in the context of the UI thread, whereas this run method is running in the background in a background thread. After it sends the message to show the toast, it then goes ahead and downloads the image, calling into the context. Once it does that, it gets a new message which says display image, and it gives it the image as the object parameter, and then it sends that message to the message handler. And as you can see here, that will run in the main thread, in the UI thread, and that handle message call will display that object via the display bitmap call. Down here, we simply create a new thread, start the thread, and then the interaction takes place with the background thread that's creating messages and passing them to the foreground thread. And here's where the handle message method gets run in the handler that's running in the context of the user interface thread. Here's just the cancel method. It does what we did before. It shows a toast and then interrupts the thread, just help shut things down. Okay, the last strategy here is Async Task. This one implements image strategy. It creates an Async Task object. Download and display method here goes ahead and creates a new Async Task, which is going to pass the URL and then use a bitmap to be passed as the result of do in background. So the URL is passed to do in background, and then the bitmap is returned from do in background, and the bitmap is also what's passed to on post execute. Here's on pre-execute. This runs in the UI thread. This goes ahead and pops up a toast saying that we're downloading via the async task, so it runs in the UI thread. Do in background runs in a background thread, as the name implies. It simply goes ahead and calls download context, download bitmap. So and this can block because it's running in a background thread. And then when that's finished, it'll return a bitmap as the parameter, or sorry, as the return value, and that is then passed as the parameter to on post execute, which runs in the context of the user interface thread and displays the bitmap. Here's the execute method that is used to actually run this async task, and that will then go ahead and spawn, or it'll pass the request to a background thread. This execute method uses the serial executor, as we've talked about in the last lecture, and that means there'll be one of these calls per application, or sorry, per process, one at a time. Here is the cancel method, which shows a toast, and then it goes ahead and cancels the async task, which we stashed away. Final class here is the download context. This just stores all the state the various strategies need to do their job, keeps track of the URL to download, keeps weak references to the view, the presenter, and the model so they can be accessed appropriately, keeps track of the completion command that it needs in order to be able to say when it's finished. Here's the constructor. It sets up all the various fields. We have a couple accessor methods to get the URL, to be able to download the bitmap, which reaches around into the model layer to do that. Show toast reaches around into the view layer to show the toast, and display bitmap will go ahead and set the image properly and then display the image in the view layer. So it sets the image in the presenter layer so that the presenter layer knows what image is the current image. In case the phone is rotated, it knows how to redisplay that image. And then display bitmap is used to get the image displayed in the context of the user interface thread. The reset bitmap simply goes ahead and resets the bitmap to the original default image. So that's basically that implementation. People had said that they wanted to see more code, so I thought this would be a good example. And it's a good example for a couple reasons. First, it's a good example because it's a really nice illustration of how you can use patterns like factory method and strategy and model view presenter in order to be able to make the overall structure of the application a lot cleaner and more extensible, because it's easy to add new concurrency strategies or image strategies without having to change other parts of the application. So that part's really clean. The use of the model view presenter pattern means that we can rotate the phone, and that doesn't perturb the threads that are running in the background doing the download. So that's nice and clean. Those are decoupled. So those are some reasons I showed it. And of course, another reason I showed this was that this is very similar to your assignment number 3, although your assignment number 3 does a few different things. So you might choose, if you are so interested in using this as the model for assignment number 3, although you are under no obligations whatsoever to do that. Assignment number 3 is intended to be done in a way where you can do it in whatever manner is most suitable for your needs or your interests. So you're welcome to use this example. You're welcome to use the much more powerful material design-based skeletons that I loaded yesterday and are on my GitHub account. You're welcome to use that as the skeleton if you want, or you're welcome to ignore all of the stuff I provide you, and you can build the whole thing yourself using whatever techniques you find most useful for you. So assignment number 3 can be done a whole bunch of different ways. Okay, let's go ahead and take some questions. How can we stop being threads when the simulation activity is destroyed? Well, that's really quite simple. What happens is that the being threads will simply be shut down successfully when you stop the being thread. Let's go ahead and look at the code. This is worth taking a quick look at. Let's see if I can go back and find the code for you, and we'll look at it. Let's see. All right, I've obviously got to go. Here we go. All right, so let me share my desktop. So remember, the question here is, how do we stop the being threads when the simulation activity is destroyed? So what happens, let's go over here and look when the simulation activity is destroyed. The shutdown method is going to get called. And let's see. So one thing that's happening here is we're indicating the simulation is no longer running. So that's one thing that's going to happen. But there's more to it than that. Let's see. Let's go over here. We'll go look at the presenter layer. Oh, before I show you this, though, here's being runnable. So you'll notice that being runnable is going to have a run method. And this run method is going to keep looping. And it's going to keep looping until either it's finished gazing, so it's gazed its last gaze in its gaze iterations, or it's going to keep running until it's told to shut down. And of course, it's told to shut down when you click the Stop Simulation button. And we'll see how that works in a second. So when a being thread is shut down, that's going to cause this loop to exit. And when this loop exits, that causes the run method to return. And when the run method returns, the thread goes away. So that's what's going to happen. The thread will just go away. Okay, so that's how the threads are going to go away. So the question was, how do we have the threads go away? Let's see how we stop the threads. So you have to go over here and you take a look at being thread. You see that there's a method here called shutdown. And when shutdown is called, it sets mShutdown to true. So mShutdown is a static volatile Boolean. And so whenever this thing is set, then all the threads that are running here, when they loop back around again and they call being thread is shut down, when they call that method call, that's going to cause this check to see if the mShutdown volatile Boolean that's static has been set to true. And if it's set to true, that's an indicator that this thread needs to basically break and stop because it's a voluntary shutdown model. Okay, so that's how that works. And then when somebody types stop simulation, if we can find that down here. So when somebody types the stop simulation, when that button is pressed, that's going to cause the shutdown method to be called. And what shutdown does is shutdown goes ahead and calls being thread shutdown, which sets that static volatile, which then causes all the threads that are running in the loop to recognize that, and then they are going to go ahead and stop themselves. So that's just classic Java voluntary thread shutdown or thread interrupt or thread cancellation, whatever you want to call it. And then, of course, we also inform the user that we're shutting down. So that's how being threads get destroyed. When they run off the end of run, they get destroyed, and they run off the end of run when they're shut down. And they're shut down under a couple of different situations, but you can either explicitly stop the simulation or an exception might occur. If you want to explicitly stop the simulation, then you need to take a look up here in run simulation. Oh, and sorry, here in simulation button pressed. So when the simulation button is pressed, if the simulation is currently running, we tell it to shut down. So that's basically how that whole thing gets started. Okay, good question. What's a good use case for the strategy pattern? Well, I just gave you a good use case for the strategy pattern. The good use case for the strategy pattern was for the image download application, and we used the pattern in order to be able to have a common interface for being able to download and display images using different concurrency models. So what we were strategizing there, the strategy part, the part that was varying behind a common interface. Remember, the common interface had download and display image. That was one method, and the other one was cancel. Those were the common methods in the strategy interface, the image strategy interface. And so the strategy pattern was simply allowing us to have different concurrency models that were all created and called via a common interface. So that's a great example of strategy. And the download context that you saw there provided the context that the strategies needed to do their job. And that gave information like the URL to download, the various ways of accessing the view, presenter, or model layers, ways of being able to have the completion hook called back, and so on and so forth. So that's a great use case of the strategy pattern. Strategy is probably my favorite Gang of Four pattern. Can you please describe how to check whether some code is running in the background thread or the UI thread? Sure, happy to do that. I had shown that earlier, but I went by it very quickly, so let's go ahead and take a quick look. Go over here. This is such a useful thing to do. I stuck it into the utils file. And so if you take a look down here, you'll see there's a method called running on UI thread, which returns true if you're running on the UI thread. And all you have to do to check to see if you're running on the UI thread is to check to see if the current thread is the same as the main looper thread. So the looper, every Android application has a looper, and the main looper is the looper that's running in the UI thread. And so if we check to see what the thread is in the UI thread, and if that's the same as the current thread, then we know we must be running on the UI thread. So that's just a simple way to check that. There are probably other ways to do it as well. I know there's several other ways to do it. That's the way I tend to like. Okay, next question. Can you please explain again what is initialize the semaphore to use a fair implementation? Sure, let's go take a look at that code as well. Go over here. So now we're going back to where we were before. We're back to the Palantiri stuff. And we'll go look over in the model layer. The really cool thing about the model view presenter pattern is you always know where to go look for stuff you need. It's always in a very, it's one of three places, or maybe four if you count the other stuff like common. So down here, we created our semaphore, and we passed in the value true. And when you create a semaphore, please go back and watch the video we had from week 1 about semaphores. Java semaphore video will explain all this stuff. So I will give you a very quick summary, but if you want more details, go watch that video. So there are two different types of semaphores, fair and non-fair. Non-fair semaphores, when you release a non-fair semaphore, the underlying virtual machine and operating system will just sort of haphazardly pick whatever thread they like best based on a variety of optimizations and runtime conditions, and they'll just let that semaphore, they'll let that thread get that semaphore. That's what's called haphazard notification. If you give a true, however, that says to use the fair implementation. And fair means that the thread that's been waiting the longest is the next one to get the semaphore. So another way of saying that is it uses first in, first out, or FIFO semantics. And the way that works under the hood is it uses something that's called the abstract queued synchronizer framework, which is part of Java. And the abstract queued synchronizer framework supports different modes, fair or non-fair. And in this particular case, the fair mode uses the specific notification pattern to notify the thread that's been waiting the longest. So that one is the one that will receive the next semaphore when there's one to be released. So that's what's called the fair implementation. So go back and watch that video and you'll learn more about that. In assignment 2, where do I get Palantiri presenter instance from in the factory class thread factory to create the being thread? You get it from the same place that you would get anything else. I'll go show you. Let's take a look at this. Share my screen. For this question, we're going to have to go over to the POSA 15 directory, and we'll go look at assignments, and we'll go look at assignment 2, and we'll step down in here, and we'll go find this, and we're going to get the thread factory. So we have thread thread factory. So here's the thread factory. You'll see that thread factory is nested inside of Palantiri Presenter. So that allows it to be able to access the various fields in Palantiri Presenter. And you'll see right up here, here is the, these are some of the fields we could have. In this particular case, the answer is super duper 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 easy, because if you want to get access to the Palantiri Presenter inside of this thread factory, you just have to be able to refer to this object for the Palantiri Presenter. So I won't say any more than that, because I'll just be completely giving away the solution. But it's really, really, really easy. And you just have to think to yourself, in what context is thread factory being created, and how would I be able to name the Palantiri Presenter from that context? So that's all I'm going to say, because I really don't want to completely give it away, but it's very easy to do. Let's see. Another question. In Palantiri release, is it not sufficient to do the reverse of what was done inside the acquire method and only release afterwards if Palantir not equal null? Let's see. I'm not entirely sure what you're asking, so let me go over to the source code and we'll look at it, and I'll see if I can understand what you're asking, and then we will feel free to follow up if I don't quite give you the answer that you're looking for. All right, so here we are, Palantiri manager, release method. So in this particular case, we come in and we're going to do a little bit of sanity checking here. And again, there are different ways to do this. You could just call release if you wanted to, but I want it to be a little smart, because if somebody passed in, if somebody had gotten the protocol all screwed up with putting the wrong Palantiri in or calling these things the wrong number of times, I don't want to just release stuff willy-nilly if the parameters are not correct. So yes, you could certainly not do this check, but this is just a little bit more sanity checking to make sure you don't have errors compound themselves. Let's see. Next question. How can one start a runnable from on progress update such that it doesn't throw a called from wrong thread exception after being passed by publish progress of the async task? Okay, so let me go, and I think I know what question you're asking. Let's go take a look at the code in question, and I will share that. So this will require us to go back a bit. Let's see, we need to go over to 15. All right, let's see, POSA 15. In assignments, this is assignment number 2. Go down in here a little bit, and we will find presenter layer. All right, so I think the question that you're asking here, if I'm not mistaken, we have on, oops, let's see, on progress update. There you go, on progress update. Okay, so here's on progress update, and here is the actually this is in being async task, so that's the on progress update. And then in here, inside of the do in background method, right, which is running in a background thread, you're going to have to make the appropriate call to publish progress, right? You're going to have to call something, and that's going to have to return a runnable. Now, this isn't too hard to figure out where to find that runnable. If you go over and look in the view layer, you'll find that all these various methods in here, like mark being, well, actually more like mark free, mark used, mark idle, mark interrupted, blah, blah, blah. All these various methods are going to go ahead and return runnables, right? So obviously, if you look at this code for a second, you're going to realize where you're going to get the runnables from. And then you have to go ahead and get those runnables, and you have to pass them to on progress update. And it's pretty obvious you're going to have to call the publish progress method to do that, and you'll give it the runnable. And then down here, on progress update is going to be called. And if you recall the discussions we've had over the past couple of weeks about async task, you know that on progress update is always called in the context of the UI thread. So when publish progress gets called, that's going to call on progress update in the UI thread with this parameter. And I will leave it up to you to figure out how to do this. Again, it is absolutely absurdly easy to do. And you don't need any extra handlers. You don't need to do a run on UI thread, blah, 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 blah. You are already running in the UI thread. So it's really, really, really simple. I don't want to give it away because it's just so obvious. But I will tell you that it's incredibly simple, and you don't have to worry about doing any other things with handlers or runnables or anything in order to make it work. Okay. So another question about calling the synchronized loop. I'm still not entirely sure what you're getting at, Sylvester. So why don't you go ahead and you can either ask the question again, or you feel free to post it on the discussion forum. So all I'm seeing there is just the code that's in the implementation of Acquire, which I have. Okay, well, if there's any other questions, feel free to ask them. Assignment number 3 is now out. You can go ahead and take a look at the material on the web page. The assignment description is there. The rubrics are there. Next week in the virtual office hours, we'll probably kind of walk through the skeletons in more detail. But again, you're not obliged to use anything I provided. This is a chance for you to be maximally creative or not. You're welcome to be creative or not be creative, whatever you find most appealing for your own interests and your own needs. And so this just gives you a chance to write a program. You can write it from scratch if you want. You can use my shells, various shells, as a starting point. You're welcome to use the model view presenter pattern framework we've got or not. It's really up to whatever you'd like to do. So with that, it looks like there are no more questions. So I will look forward to talking to you all again next week. We'll probably only have one lecture next week, which will be the virtual office hour on Thursday. And that's where I will go over my solution to programming assignment number 2.